How's it going, guys? Today in this video, we're going to be going over the first half of the review sheet in the packet or your notes. So anyways, go ahead and just get started. Number one, we're told if you have a polynomial function, x equals a1x plus b1x times a2x plus b2x and a3x plus b3, or a3x plus b3. We're going to describe the constant term and the leading coefficient in terms of a and b. So the constant, remember, the constant term will be all the terms right there without an x variable. Sorry. So we're going to multiply all of them together. So it'll be b1 times b2 times b3. That will give you your constant term. And then for the leading coefficient will be all the a's multiplied with each other. Or in other words, all the coefficients of x. So a1 times a2 times a3. And if you want it, it may be in terms of numbers, so you can actually see what's happening. If we have, say, 2x plus 3, x minus 7, and 4x minus 2, our constant here will be 3 times negative 7, which is negative 21, times negative 2, which is a positive 42. You multiply all the terms without an x. So 3, negative 7, and negative 2. The leading coefficient, we're going to multiply the coefficients in front of the x. So the 2, the 1, and the 4, which is just 8. 2 times 1 is 2, 2 times 4 is 8. So that's how you do it in terms of a and b, and if we actually had real numbers instead of just variables, okay? For number 2, we're asked to list out the two possible third-degree polynomials where negative 5 and 2 are our only zeros. We're going to write them both. So if we have a third-degree polynomial, that means we have to have 3 zeros. And if we only have 2 possible zeros, which are negative 5 and 2, that means one of them has to have a multiplicity of 2. It has to happen twice. So one of our possible polynomials will be when negative 5 has a multiplicity of 2. So you have x plus 5 squared and x minus 2. And our other polynomial will be when 2 has a multiplicity of 2. So x plus 5 times x minus 2 squared. And we can see both of these polynomials have a degree of the third power, but they have different multiplicities for the zeros. In the first one, negative 5 has a multiplicity of 2, and in the second one, 2 has a multiplicity of 2. That's how you have a third-degree polynomial with only 2 possible zeros. Okay? Let's go ahead and do number 3. We're told a jewelry box has a length as 1 inch shorter than the width and a height as 2 inches larger than the width. The volume of the box is 72 cubic inches. We need to find the dimensions of the jewelry box. So we're going to ignore this part right here where it says let x represent the base width, because we need to be able to figure that out by ourselves. And we can figure that out by just seeing that the length and the height are both being represented in terms of the width. Right, they're being compared to it. The length is 1 inch shorter than the width, and the height is 2 inches larger than the width. All right, so everything's being compared to the width. So if everything's being compared to one thing, that thing is probably going to be your x. Very likely it will be your x because everything's being compared to it. So we want to write our equation in terms of it. All right, so width is x. Our length will be x minus 1. And our height will be x plus 2. And we're told our volume will be 72. So now we're going to put everything into our volume formula. And in this case, our volume formula is length times width times height. So we're just going to multiply, or rather plug everything in. So 72 equals our length, which is x minus 1, our width, which is x, and our height, which is x plus 2. Okay? So we're going to multiply everything and move the 72 over. So we'll move the 72 over, we get 0 equals, we'll multiply these two as well. So x squared minus x times x plus 2 minus 72. So I multiply x minus 1 and x, and I move the 72 over to the other side. I'm going to keep multiplying everything. So x squared with x is x cubed. X squared with 2 is 2x squared. Negative x with x is negative x squared. And negative x with 2 is negative 2x all minus 72. We'll add like terms, x cubed plus x squared minus 2x minus 72. That all equals 0. So now that we have our function in standard form, what we can do from here is we can actually do our synthetic division and try to figure out which factors actually works. All right. So we need factors of 72. There's a whole bunch of them. So all our factors of 72 will be plus or minus 1, 2, 3, 4, 6, 8, 9, 12, 18, 24, 38, and finally 72. Right? So that's a whole bunch of factors, but that's all our factors of 72. Okay? But before we actually start testing them out, what we want to do is actually eliminate as many as we can. The first thing we could eliminate or can eliminate are the negatives. Negatives doesn't make sense in a problem like this because our width is in terms of x. So if you have an x value that equals a negative number, that doesn't make sense because you can't have a negative width, right? You can't have something that's like negative 3 inches long. It doesn't make sense. Okay, so we can cross out all the negatives. And next, we can also cross out the 1. And that's because our length up here is x minus 1. And if our x equals 1, then our length, will be 0. You can't have a length of 0 inches. It doesn't make sense. That means it's non-existent, and it doesn't work that way. Okay? So we can cross out all the negatives and the 1. So now we can start testing with the 2. I'm not going to keep testing these out because when we keep testing them out, we realize that 4 is the one that works. But when you're working problems yourself, you're going to have to start testing. You're going to start testing it from the beginning. That's the best course of action. So you start with the 2. You're going to realize it doesn't work. Then you're going to start with the 3. Realize that doesn't work. And then you test with the 4, which does work. All right, so I'm going to jump right to the one that does work. That's 4. We put out our coefficients from our polynomial that we found out ourselves, which will be 1, 1, negative 2, and negative 72. So we do synthetic division with our 0 being 4. So drop down to 1. 4 times 1 is 4. 1 plus 4 is 5. 4 times 5 is 20. Negative 2 plus 20 is 18. 4 times 18 is a positive 72. And negative 72 plus 72 is 0. So our remainder is 0, which is exactly what we wanted, what we expected. So our factored form will be x minus 4. That's from our 0 over here. And we're going to multiply it with our quotient right there, x squared plus 5x plus 18. And we can see that x squared plus 5x plus 18 doesn't factor out anymore. There's no factors of 18 that add up to give you 5. Okay? So what we're going to do instead is we're going to take that 4 because we don't have any other possible answers and plug that into our terms up there. So our x is 4, so our length will be x minus 1, which is 3. Our width will be 4, and our height will be 4 plus 2, which is 6. And we can double check our work to make sure everything works. 3 times 4 is 12, and 12 times 6 is 72. So our length times width times height does equal the volume that we were given. So that means we got the right answer. Most likely got the right answer. Let's put it that way. Okay? So let's keep on going. Number 4, I'll let you guys do on your own. We do post a completed key. It should be up already if you're watching this video. So you can go ahead and double check your work on that. For number 5, we'll work through this one. So we're told to solve the polynomial equation by finding all the roots. And we're going to rewrite each polynomial as a product of its factors. Or in other words, we're going to factor this all out. Or factor it as much as we can. Okay? For number 5, the first thing we can do is actually take out the GCF. Remember, if you're ever factoring stuff out, the very first thing you always want to do is look for a GCF. And in this case, there's a GCF of x. Everything's being multiplied by x. So we can factor out that x, and we'll be left with x cubed plus 8x squared plus 24x plus 32. Okay? So x is completely factored. We don't need to worry about that anymore. But this x cubed plus 8x squared plus 24x plus 32 can still be factored out. We can't do factor by grouping in this case, so we need to do synthetic division. And our synthetic division will be with factors of 32, which will be plus or minus 1, 2, 4, 8, 16, and 32. All right. So that's going to be all our factors of 32. And now we're going to start guessing and checking, or not guessing and checking, I don't want to say it that way, but rather we're going to be trying out all our possible zeros until we find one that works. All right. And in this case, we find out that -4 is actually a possible zero. I'm not going to go through all the guessing and checking, but -4 is a factor that works. So we're going to do our synthetic division with -4 and put our coefficients from this factor here. So 1, 8, 24, 32. We'll drop down to 1. -4 times 1 is -4. 8 plus -4 is 4. 4 times -4 is -16. 24 plus 16 is 8. 8 times -4 is -32. And we get a remainder of 0. Okay? So what we do from here is we're going to first bring down this x. We cannot forget about the GCF, so we're going to bring it down. So we have x times our 0 that we have over there. It worked, so we have to bring it down. Our 0 in that case will be x plus 4. Since if we put x plus 4 equal to 0, that gives us x equals -4. That's what we want. And we're going to multiply both of these with the quotient we just got over here. X squared plus 4x plus 8. Okay? So we still have an x squared here, so we're going to check if we can factor this down anymore. And it comes out that we can't. There's no factors of 8 that add up to give you 4. So in that case, we're done factoring. This is our completely factored out form, but we still need to figure out our zeros. So and to figure out our zeros, we're going to set every single x value equal to 0. Or rather, each factor equal to 0, and each factor has an x term in it. So first, we have this x, the GCF of x that we took out. So x equals 0. That is 1, 0 by itself. Next, we have x plus 4. We'll set that equal to 0. Or x equals -4. And that's another 0. And last, we have this x squared plus 4x plus 8, all equals 0. Okay, so now we can solve this for our x values. Remember, we cannot factor it, so doing the box method or any other method won't work. Our only option here is to use our quadratic formula. So it's going to be -4 plus or minus the square root of b squared, which is 16, minus 4 times a times c, which is 32, all over 2a. Our a is 1, so it's just 2. Okay? So -4 plus or minus the square root of 16 minus 32 is -16, all over 2. The square root of -16, we can pull out an I first. So it's -4 plus or minus I square root of 16. Remember to take the negative out of the square root. You put an I in front of the square root and get rid of the negative. That's what I did. It's all over 2. The square root of 16 is 4. So we have -4 plus or minus 4i all over 2. The -4 and the 4, they can be reduced by the 2 underneath it. So it becomes -2 plus or minus 2i. And that right there, remember, it's two different zeros. -2 plus 2i and -2 minus 2i. And that's our 4 zeros. X equals 0, x equals -4, and x equals -2 plus 2i and -2 minus 2i. And we should actually set this equal to x just to be consistent. So this all equals x. All right? So from here, let's actually skip on over to number 12. Okay? So let's go on to number 12. We have x to the 4th plus 5x cubed plus 6x squared minus 4x minus 8. So it's a whole bunch of numbers. So, and we need to factor this out. All right? So we can't really do factor by grouping. We have 5 terms. So we really don't have any other option but to do synthetic division. So our possible zeros for this function, it's actually just keep it with 8. The negative doesn't matter since it's already a plus or minus with all our factors. So it's 8 plus or minus 1, 2, 4, or 8. Those are our possible zeros. And we're going to divide it with our quotients there. So I'm going to go with 1. I've done this problem already, so I know 1 works. But usually you're going to have to kind of guess and check. We're going to start from the very lowest number. So you go 1, -1, 2, -2, so on and so forth. So we're going to start with 1, and our coefficients are 1, 5, 6, -4, and -8. Okay. So we're going to bring down the 1. 1 times 1 is 1. 5 plus 1 is 6. 6 times 1 is 6. 6 plus 6 is 12. 12 plus 1 is, 12 times 1 is 12. -4 plus 12 is a positive 8. 1 times 8 is a positive 8. -8 plus 8 is 0. So when we divide this with a 0 of 1, we get this quotient here. So we can rewrite this. We can take our 0 that we just got and put it down here. So x minus 1, since that x minus 1 tells us that a 0 is 1, which is what we divided by. So x minus 1 times x cubed plus 6x squared plus 12x plus 8. All right? So from here, it's the same thing. We can't really, well, sorry, for this part right here, we can't really do factor by grouping. It's not going to work. So we have to do synthetic division again. And it's with factors of 8 again, since that's what we have as a constant. So our factors of 8 are plus or minus 1, 2, 4, and 8. So we're going to do synthetic division again with our new polynomial inside the parentheses. So when we do it, we'll know that -2 is the one that works. I'm not going to keep guessing and checking. We've already done this problem. But -2 is the one that works when you do this problem. So we have 1, 6, 12, and 8. All right? And we're going to divide with, start with the 0 of -2. We'll drop down to 1. We get 1. -2 times 1 is -2. 6 plus -2 is 4. 4 times -2 is -8. -8 plus 12 is a positive 4. And 4 times -2 is -8, which gives us a remainder of 0, which is what we want. Just a quick reminder, I should have said this earlier, but when we're doing synthetic division, we always want a remainder of 0, because remember, a remainder of 0 tells us that what we're dividing by, this a value here, is a 0. So we get a remainder of 0. What we're dividing with, at -2, for instance, that's a 0 of the whole polynomial. All right? So that's what we're looking for. If you get anything other than a 0, that number is pretty much useless to you. It's not a 0. Forget about it. Move on. Just a quick reminder. All right? So now we have another 0 here. We're going to bring down our first 0 of x minus 1. And we'll bring down this new 0 of x minus -2, or x plus 2. And we're going to multiply it with our new quotient over here of x squared plus 4x plus 4. All right? And luckily, we can see that x squared plus 4x plus 4 can be factored out normally. It's just going to be x plus 2 and x plus 2. All right? So it's x minus 1 times x plus 2 and x plus 2 times x plus 2. Okay? Or in other words, it's going to be x minus 1 times x plus 2 cubed. So our answer here will be 1, well, x equals 1, and x equals -2 with a multiplicity of 3. Or you could write it as -2, 3. However, your teacher told you to write it that way. Just know that -2 has a multiplicity of 3. Okay? All right, so that's 1 through 12. This is going to be the first video. Hopefully it was helpful, guys, and the second part is going to be up as well.